Hello everybody, and welcome to topic number 12, polynomial multiplication. In this video we're going to teach you some of the skills that we need to multiply polynomials set up in different types of formats. A quick review of some exponent rules we're going to need as we go through this. We remember that if we multiply variables with the same base, then we add the exponents. So for example, if I have x to the third times x squared, then I will simply do x3 plus 2 and get x to the fifth. Again, we could do that also with multiple variables. If I have a to the third b squared and I multiply it by a b to the sixth, it's the same idea, but we're going to do it with each of the letters. For the a, we're going to do a 3 plus a 1, because if there's no exponent written there, we remember that that is a 1. And then for the b, we will do 2 plus 6. So this will end up being a to the fourth, b to the eighth. We will keep this general guideline as we go through and do polynomial multiplication problems. Multiplying monomials by monomials. So again, monomials are those that have one term. All we're going to do is multiply the coefficients, the numbers out in front, and then we'll add the exponents like we just showed you. So for example, when I have 4x to the fourth times 3x to the fifth, I'm really just doing 4 times 3, and then I'm adding the exponents of 4 and 5 together. 4 times 3 is 12, 4 plus 5 is 9. So in this case, we get 12x to the ninth. We'll do the same thing over here. We'll do the coefficients will multiply with each other. So negative 8 and 4 gives me negative 32. We have a3 and a2, so we'll add those together. And then we have b to the first. Remember, no exponent, we put a 1 there if we need it. B to the first to the sixth power. So our final answer should be negative 32, a to the fifth, b to the seventh. So when we do monomials, we'll multiply the coefficients by each other, and we'll add the exponents of like variables. Multiplying a monomial by a polynomial. Same idea, except we're going to use our knowledge of the distributive property. We take what's on the outside of the parentheses and we multiply it by the inside by every term. Again, we'll multiply coefficients by themselves and then we'll add the exponents. So for example, I'm going to take this negative 3 and I'm going to distribute it to all three terms here. And I'm going to do 3 times 2, which gives me 6, x times x squared. Remembering that this x is really x to the first power, so 1 plus 2 gives me 3. 3 times negative 1, because again, if there's no number out in front, we can pretend like that's a negative 1, is negative 3. x1 becomes x squared. 3x times 4, 3 times 4 is 12. Here we have an x, we don't have any x's here, so this polynomial will stay with 1x. Let's do it again over here. We see we've got 3 terms again. Each one of these is going to go to its own terms. We remember from the previous video, terms are what's separated by plus and minus signs. So we've got to make sure that everything on the outside goes to everything on the inside at least once. Here we're going to do 6 times 5, which gives me 30. I've got x4 and x squared, which will combine together to give me x6. This y3 doesn't have anything to multiply with, so the y3 comes down with it. 6 times negative 6 is negative 36. X to the fourth and x squared, again, gives me x to the sixth. Y cubed and y to the first power gives me y to the fourth. 6 times 3 gives me 18. I have an x4, and this term doesn't have any x's, so we'll keep that as x4. y3 and y4 make y7. So same thing as we did before, just with multiple terms as we're doing the monomial into the polynomial. Multiplying binomials. So again, a binomial is something that has 2 terms. What if we multiply a binomial by another binomial? To help us remember it, we use this acronym FOIL to be able to help us remember how we're going to do it. The FOIL stands for first, outer, inner, and last. And what that means is, for first, we're going to take the first two terms of each binomial and multiply them together. So in this case, a and c would be the first two terms. Next, we're going to take the outer terms. We're going to take a again and c, because they're closest to the outside, and this would be the outer terms, and we would multiply them together. Next, we're going to do the opposite. We would do the inner. If a and d are the outside, b and c would be the inner. So we would take these two and multiply it by each other. And finally, we would do the last. If a and c are the first terms, then b and d are the last terms. So if you really take a look, we're just making sure everything in the first binomial gets multiplied by everything in the second binomial. When we're done multiplying, we'll go through and make sure, see if we have any like terms to combine at the end. So here in my example, I've got x plus 3, x minus 8. The first would be x times x. The outside would be x times negative 8. The inside would be 3 times x. And then the last would be 3 times negative 8. Multiplying that all together, x times x gives me x squared. X times negative 8 is just negative 8x. 3 times x gives me 3x. And 3 times negative 8 gives me negative 24. We have to go back now and see if we have any like terms. Nothing has an x squared and nothing is just a constant. But here in the middle, both of these terms have an x. So we can combine those when we do it. Negative 8x plus 3x will give me negative 5x. The 24 does not combine with anything as well. This will be my final answer. Again, let's do it for the second problem here. 4x minus 1, 3x minus 6. Again, the key part here is as you're doing this, make sure you watch out for your signs. 4x times 3x gives me 12x squared. 4 times 3 is 12. X times x is x squared. Then we'll go to the outside. 4x times negative 6. 4 times negative 6 is negative 24. And we bring down the x that's with it. Negative 1 times 3x. Negative 1 times 3 is negative 3. And the x comes down with it. And then finally, negative 1 times negative 6. Two negatives multiply to make a positive. Again, we'll look for our like terms. These are the only two like terms we have. Nothing else has the x squared like the 12, and nothing else is the constant here. So we'll combine negative 24 minus 3, and that will give me negative 27x. I know my problem's done when I have no more like terms to combine. X squared, x, and the constant. Nothing will combine there. Squaring a binomial. So we have to remember what it means to square a number. If I go through and I do 3 squared, I'm really asking you to do 3 times 3. Well, it's the same thing with binomials. If I ask you to square a binomial, I'm asking you to take the binomial and multiply it by itself. We could do that with the FOIL. X times x gives me x squared. X times negative 6 gives me negative 6x. Negative 6 times x gives me negative 6x. And negative 6 times negative 6 gives me a positive 36. Again, we've got like terms on the inside. Be careful here. This is negative 6 minus 6. They don't cancel out. That would become a negative 12x plus 36. Again, no more like terms, so this would be our final answer. So as we go through, when we square a binomial, we're basically going through and writing the binomials twice. 3x plus 3, 3x plus 4. And then we're using our FOIL technique to finish it. 3x times 3x is 9x squared. 3x times 4 is 12x. 4 times 3x is also 12x. And 4 times 4 is 16. Those like terms will end up in the middle. 12 and 12 make 24x. And the 16 will come down with it. So again, squaring a binomial, we're really writing out the binomial twice and FOILing out to get our final answer. What about binomials with opposite signs? So these, we'll learn later on, are called conjugates. Conjugates are just something that has basically the same insides but opposite signs. And you're going to notice, and you should be able to pick up a pattern that happens with these. Now, these are not the same as before. This is not what happens when you square a binomial. These are literally, they have the exact same terms, except one of the signs is negative and one of the signs is positive in any order. Let's take a look and see what happens when I FOIL this. X times x gives me x squared. X times 3 gives me 3x. Negative 3 times x gives me negative 3x. Negative 3 times 3 gives me negative 9. But this time, when I go to look at the like terms, they're opposites. I have 3 minus 3, which gives me 0. So it cancels. The only thing I'm left with is x squared minus 9. Let's see if this holds true even when there's a number on x. So we're going to do it again. We have 5x plus 2 and 5x minus 2. Again, these are binomials with opposite signs. It doesn't matter whether the plus or the minus is first or last. 5x times 5x is 25x squared. 5x times negative 2 is negative 10x. 2 plus 5x is 10x. And 2 times negative 2 is negative 4. And sure enough, if you take a look at the middle, I've got negative 10 plus 10, which cancels, leaving me with 25x squared minus 4. So, if you want a little bit of a shortcut or trick, if you notice you have two terms, or two things, binomials with opposite signs, then all you need to do to get the answer really is do the first times the first and the last times the last. It should always come out with something minus something. You really don't have to do the middles of the binomial if you want. You only need to do the first and the last. You can go ahead and FOIL it out if you want as well. You will just take a little bit longer to get to the answer, but that is okay. That's just a trick and a shortcut. But again, it only works for binomials with opposite signs. It does not work if they have the same signs. They must have the opposite signs to be able to use that trick. Finally, what happens if we want to multiply a binomial by a trinomial? Well, we're really just using the distributive property twice, or we're thinking about it, it's just a longer version of FOIL. And understand, in FOIL, all we're really going through and doing is making sure everything in the first binomial gets multiplied by everything in the second binomial. So what I'm doing here is I'm going to take this 2x and I'm going to make sure it multiplies everything in this trinomial over here. So 2x times 4x squared, and then I'm going to have 2x times negative x, and then I'm going to have 2x times 3. When I do those, 2x times 4x squared is 8x cubed. 2x times negative x is negative 2x squared. 2x times 3 is 6x. Now we're going to take the negative 5 and do the exact same thing. We'll take the negative 5 and it'll get multiplied by these three terms as well. So I've got negative 5 times 4x squared, negative 5 times negative x, and negative 5 times 3. Negative 5 times 4x squared is negative 20x squared. Negative 5 times negative x, two negatives make a positive, so this is just 5x. Negative 5 times 3 is negative 15. So I really have 6 different parts. I have to go through and see if any of these will combine, and I want to make sure I write my answer starting with the biggest exponent. So I got 8x to the third power here. There's nothing else to the third power, so we'll use that 8x3 to start it out with. We notice that we have a negative 2x squared and a negative 20x squared. Those will combine. Negative 2 minus 20 will give me negative 22x squared. Same thing here with the 6x and the 5x. Those are like terms, so we're going to combine them as well. 6x plus 5x gives me 11x. And the negative 15 doesn't have anything to combine with, so it goes at the end. I know, again, I'm done. When I have nothing else to combine, I have no other like terms here. So don't be afraid if you see something longer like this. It's all the exact same components as FOIL. we're just doing it a little bit longer. Everything in the first term is being multiplied by everything in the second term. Some common mistakes to avoid as you go through this. Forgetting to multiply every term. Make sure you draw those arrows and make sure everything is being multiplied by everything at least one time. Make sure you use your exponent rules correctly. When you multiply things, you add them, but they have to have the same bases. And make sure we check and see if we can combine like terms at the end. And make sure we remember, when we combine like terms, the big thing here is the exponent does not change. Sometimes that's a little bit confusing. When we multiply, the exponent does change. When I do x to the third times x to the third, the exponent becomes x to the sixth. But if I do x to the third plus x to the third, as long as they're like terms, we would combine the coefficients that's in front, and I would get 2x to the third. So make sure we watch out when we combine like terms that the exponents does not change. If you do all this, you will be successful as you go through and multiply polynomials.